So let's move on to question number 5. So we're asked to use the function that we've created to estimate the cell phone users in 2005. So remember, 2005 is how many years past 1996? Right? Our table goes from 1996 to 2000, with 2000 being 4 years after 1996. So 2005 would be 9 years after 1996. So when I go back to question number 5, this is the equation I'd have to solve, right? I'm going to replace the t with the 9. So I get my calculator ready, and I'm going to enter the equation just the way we see it. So here I've entered the equation into my calculator, 44.248 times 1.25 raised to the 9. Again, if you have an older calculator, you might actually see this caret symbol after the 5 and before the 9, and that's fine. I press enter. So this gives me my answer of 329.67. So my answer is 329.673 cell phones in millions, or you could say 329,673,000 cell phones. That's how many phones we predict in 2005, according to our model. Do I think this is a good estimate? I'm going to say no, because this is an example of extrapolation. Right? This 2005 falls outside of our supplied data. Right? If we take a look at our table only gives us accurate data or exact data for the years 1996 through 2000. 2005 is outside of this table, so it's an example of extrapolation, and I think extrapolation that gives us results, but I think they're less reliable once you start to move away with the supply data. Part 6 says use the graph of the exponential function and the trace or table feature of your calculator to determine the number of years it will take for the number of cell phone users to double from 44 million to 88 million. So again, here is my equation, right? That 44.248 times 1.25 raised to the x. I press graph. There's my graph. And we want to know how long does it take to go from 44 million users to 88. And it says we could use the table or the trace feature. So if you press the trace key, you can see here my y equals 135. We want to know, when does y equal 88? So I'm pressing the left arrow, and this is going to give me an answer. It's not going to be perfect. Right, here's 87. So this is a little bit more than 88. This is 88.491, and we're looking for 88.496. So this is close enough. So it looks like it's going to take about 3.1 years. Right? It will take about 3.1 years to double the number of cell phone users. Okay. Now the next question says, well, how about going from 88 to 176? Now, remember, if you press your window key, my y only went to 175, and they're asking for 176.99. So I need to increase my y max. And so I got to this screen by pressing the window key, and I'm going to change 175. I'm going to make it 200. Okay, so now when I press graph, my graph will extend a little bit further. And again, we want to know how long does it take to go from 88 to 176. So if I press the trace key, I can move my arrow down to make this y equal to 88.49, or get very close to it. 88, there we go. So on the side here, I've recorded, okay, when x is 3.1, y is 88.492. So I want to know how long does it take to double. So remember, this x, this 3.1, represents the number of years past 1996. So to double, to go from 88 to 176, well, I'm going to press the right arrow until I get to this 176 number. Looks like I have to press it quite a few times. Oops, I went past it. Here we go, 176.97. So that's close enough. So I'm going to write my value of x and y. So when I take a look at this, right, we have years since 1996. So we went from 3.1 to 6.2. So the difference here is still 3.1. So we can write it will take 3.1 years to double users from 88.496 million cell phone subscribers to 176.992 cell phone users. So it looks like every 3.1 years we'll double the number of users, right? From 1996 to 1999 or so, we went from 44 to 88 million users. And then 3.1 years later, we go from 88 to 176. So when it says how long will it take for any given number of cell phone users to double, basically every 3.1 years, the number of users will double. And then we're given a definition down here. It just says doubling time of an exponential function is the time it takes for an output to double. The doubling time is determined by the growth factor and remains the same for all output values.